Hey, so I bet some of you are thinking, this lab, best thing ever, but I've got to do some calculations. Oh my gosh, I'm confused. Well, that's what this video is for, to help. So here's some sample data, okay? This is not data that you got. This is data that is Mrs. Thorburn's data, okay? Use your data here, not mine, because you have different metals than what I used. Okay, this is called sample data. You want to put your numbers here, okay? So first, this is the mass of the water. What volume of water did you use? The mass of the water and the volume of water are the same thing. So it says milliliters. In grams, it's the same thing. How much water did you use? What was the initial temperature of your cold water? That goes there. When you put your metal and your water together in the same cup, that's the final temperature. That's why these are the same number, because they were in the same cup. Right here, in my change of temperature, I did my final minus my initial. Okay, final minus initial. This one is negative because my final temperature was colder than my initial temperature. You're always going to have a negative number whenever you're cooling something down. So, whenever you're cooling something, your delta T will always be negative. So here are my calculations. All right, so for my mass of water, I had 100 grams of water. Okay, I'm going to add my units now. My specific heat of water is 4.18 joules grams degrees Celsius. This is a standard number. We know it's water. Okay, and my delta T of water, as you saw in my my data table, was 12 degrees Celsius. So, in order to solve for my Q, or my energy, my heat gained by the water, okay, because I was putting something hotter in there, I multiply the mass times the specific heat, mass, specific heat, times the delta T. Okay, I multiply all those numbers together, and I get this number, 5,016 joules. Okay, so now do that for yours. What mass of water did you use? Everybody will have the same specific heat and your delta T. What was your delta T? If you need to pause here to do your calculations, that's okay. Hit pause. Now, this is the most exciting part. I bet you guys are going to be like, what? Oh my God, Ms. Thorburn, I have never heard of something more exciting than this. But really, this is the most exciting thing. Okay. Look at this. This is the number we just calculated, 5,016 joules. But that is the exact same amount of energy that is lost by my metal because they're in the same system. So my energy gained by the water, because it was heated, was 5,016. Since my metal was cooled, since it lost temperature, it is the exact same number, but it's just negative. So something you can remember is when something is being cooled, it's always going to have a negative Q, okay? So we can write that down. So if we have a cooled equals negative, a negative Q, because it has a negative delta T. That helps you remember that. So in order to find the specific heat of my metal, because I didn't know, I just know it's metal, this is my data for the metal. My mass of my metal was 121.6 grams. Okay. My delta T for my metal was negative 68 degrees Celsius because I did the final minus the initial. And then I'm doing the Q, okay, which is right here. So these are all the numbers for my metal. So look at the right side of your data table to figure this out. And then you're going to end up with a number here. should be something less than 1, something close to 1. If you have something greater than that, it's possible that you're not putting this whole quantity down here in parentheses. All this part needs to be in parentheses. A helpful hint, you might want to multiply these two bottom numbers together first, okay? Figure out what you get, and then divide your top number divided by that quantity, especially if you're not using one of the scientific calculators where you can see what everything is happening. All right, so I got 0.58. What does that mean? Okay, so go into Schoology and you're going to see there's a table. It's called specific heat of various metals. You want to look at your specific heat. What number did you get? And you're going to compare it to see which one that's closest to. Since I got 0.58, that's closest to 0.5. Okay, so I'm going to say that mine was steel because 0.58 is closest to 0.50. So if you got something like 0.10, let's say you got 0.10, do you think that you would have lead or gold? Okay, both of those are very close together. You got to kind of use your common sense. In the science lab, we're probably not going to be giving you gold. We're not that rich, okay? It probably would be lead, just an FYI. I'd love to give you all gold, but you know, you guys are just treasure enough, as I'm sure I am treasure enough to you. JK. But anyway, gold is probably not something we're going to be handing out, so kind of think about that too. Anyway, so once you get what you think your metal is, we're going to do an error analysis. So on the next page, underneath where you calculated your specific heat, you've got to figure out the percent difference. So you do your experimental number. What did you calculate? Okay, that's what I calculated right here, my experimental, minus the actual value. The actual value is what is in the table. So I do 0.58 minus 0.5, and I get 0.08, and then I do that divided by 0.5, okay? And this formula is in your lab. I'm just substituting in the numbers. And then to figure out the percent, you have to multiply that by 100. So I got 16% difference. Now, if your percent difference is a lot higher than that, it's okay. You just want to kind of think, why is my percent difference so high? And in your error analysis, think of some reasons. Why are you losing so much heat? What about our lab setup is making so much heat being lost to the outside? And if it's hard for you to think about, I'm sure all of you have gotten some hot chocolate or hot coffee in your lives. What do they use in your cup to make sure that the heat stays in your cup? Something that we did not have. Think about that. All right, and finally, so you know how to do the calculations now. If you didn't, just go back, pause, go through some of the calculations in the packet on page 14, 15, and 16. And finally, it's time to write your conclusion. So you're going to be comparing the specific heats of your two different metals here. You're going to be talking about why are they different, okay? Why do two different metals have two different specific heats, and what does that mean? So look at the readings that are in Schoology to help you with the reasoning there. To make sure that you get the best grade that you can, there is a rubric in Schoology, okay? It is in the same folder where you got this document. Okay, so if you go into Schoology right here, where it says Specific Heat Lab Report, right here, this is where the rubric is, okay? It is in the assignment. It's attached there. So open that up, and as you are writing your conclusion, kind of go through there, check things off, and then you want to turn in your lab report. You've got all of class to work on this, so use your class time wisely and make sure that you get everything done. If you have any questions while you're doing this, send me an email, okay, and I can help you out. And your lab report will be due not today, but the following class period. However, you have all of class to work on it, and this is the only class time that you have, so use it well. Next class we'll be doing something else. So that's it. I hope you had a great video, and this was the most exciting thing that you've heard all day. Avi, I will talk to you soon. Bye.